So we left off somewhere in this area in your class in lesson 5.5. I had definitely set up the triangle ABC, filled in the given information. We talked about the fact that they provided side-side angle. The given angle is acute, and the side across from the given angle is longer than the other side. Okay, so that does take us into the fact that there is one triangle possible, and the information given. We're given the A's, right? And we're given AB. And so we were setting up, when we left yesterday, that sine of A over A is going to be equal to sine of B over B. And I do, now that I think about it, even remember filling in that information, didn't I? So sine of 26.3 degrees over 7 is equal to sine of B over 6. So we've gotten that far at least, right? You know the next couple of steps to take. Fraction equal to a fraction. We've got a proportion here, so we can solve using cross products. So I know that 7 times the sine of B is going to be equal to 6 times the sine of 26.3 degrees. What's my next step? If I'm trying to solve for B, we need to work to get B by itself, right? B in this particular problem is part of the sine function. So we can't quite get B by itself yet. But can we at least get sine B by itself? So that'd be the step we want to take. How do we get sine B by itself? We're going to divide by 7, right? So I'm going to write this as sine B. The sine of B is equal to 6 sine 26.3 degrees divided by 7. This is where we have to pause and think. Right now it says sine B is equal to that fraction. Well, while knowing what sine B is helpful, in reality what I want to know is, what is B? How do I find B in this situation? If the piece I'm trying to find is within the sine, but I want this to be B equals, what allows this B in the sine and what it equals to flip-flop? What allows your input of a function and the output to switch? Do we know what I'm looking for here?
Reciprocal.
Not reciprocal, different word there.
Inverse.
Inverse. Okay, remember inverse takes an input and an output and switches. So if I want B out of sine, in order to switch this, I can switch the B and the fraction value over here and say that B is sine inverse of 6 sine 26.3 degrees over 7. Okay, so on the problems when you're provided the sign of some letter, in order to make that happen, you are, in order to get, instead of sine B to be B equals, you're taking that input and the output and you're flipping them. And that is the sine inverse function. Yes?
Is there a B before sine 26.3?
That is a 6.
Okay, sorry.
No, that's all right. 6 lowercase b's, they look a lot alike, don't they? Yeah, it's the 6 we've been carrying down. Now, how do I do this on my calculator? Do we know? How do we do this on the calculator? We don't want to do the sine of 6 over sine 26.37. We want to do what? Sorry, I had to change back to degree mode. Use my calculator and calculus. How do we do sine inverse? We're going to do the second sine function. So that was me doing second and the button, the sine button, but above it is sine -1. Yes? I didn't show that, but it's doing second, and then it's using my sine button, but giving me sine inverse. Now, definitely make sure you hit the right button there. And then from there, it's just typing in the information. So if I go ahead and set up a fraction bar, 6 sine 26.3 in those parentheses, go to the denominator, over 7, and in those parentheses. You should be getting an answer similar to mine. Not similar, you should be getting an answer exactly of mine. If I go 1 decimal place, that is 22.3 degrees. Did you get your calculator to cooperate? Okay, so that's the other type solving you're going to do when you actually have to, put them into the calculators and solve them. Okay, guys, we have angle B. We were given angle A and side A. We were given side B. We found angle B. What do we still have left to find? We have our A's, we have our B's, we need to find our C's. We need to find angle C, we need to find side C. Which one can I find first? Or which one do I have to find first? What do we know? And how do we find angle C? Sound familiar, guys? All 3 angles always add up to be 180, yes? Okay, so this is the easy piece in that the fact that angle A plus angle B plus angle C, plus angle C equals 180 degrees. So I'm not even going to bother filling those in. Do the math. Add your 22.3 and your 26.3. Subtract those from 180, and we get 131.4. One piece left to find. How do we find side C?
A sine of A over A.
Yep. Go back to our law of sines. Sine of A over A equal to sine of
C over C,
C over C, since we're trying to find C. Okay. And notice I like to date and pick the A's because those were the given pieces, right? It's not that you couldn't use the B's, but that B angle is a rounded angle, so it makes it a little more questionable. So fill in your math and do it. Sine of A, so sine of 26.3 degrees over 7 is equal to sine of C, so sine of 131.4 degrees over side C. This is the easier solving, right? You're solving for side C, nothing fancy here. So cross products, C times sine of 26.3 degrees is going to be 7 times sine of 131.4 degrees. Solve for C. So 7 sine 131.4 degrees divided by sine of 26.3 degrees. Put in the calculator, hit the magical buttons. And what's the calculator tell me? $11.9 is what I have in my notes. Sorry, no, I didn't go punch it on my calculator, but I'm not as concerned at this point. That was the easy type, right? Now, if your calculator's not giving you 11.9, let's do double checking and figure out why.
Actually, I'm getting 11.85.
But you rounded appropriately. Okay, so this was a scenario where angle A was acute and that side was bigger than the opposing side. So this is the one we looked at right here. Okay. Now we're going to go on to example B. Solve triangle ABC, given that side A is 6, side B is 7, and angle A is 30 degrees. I'm going to draw a similar triangle to what I drew last time. You know what? Before I do this, I usually go all the way up there, don't I? There's a lot I usually squeeze into example A or example B, so I'm going to give myself a little bit more room up there. Okay, so traditional triangle right here. Okay, with that triangle, they gave me A. I'm going to put A over here again as 30 degrees. The side opposite A is 6. This other side over here, I'm going to put this as B as 7. And I'm doing that because the 6 and 7 are similar in the, kind of like last time. I'm going to label my other pieces. That's angle B, that's got to be angle C, that's got to be side C. Okay. Again, like last time, side angle, yes? Provided our side angle. And our deal this time is that the side opposite the acute angle is actually smaller than the opposing side. Okay? And so when that happens, so when your angle is acute and the smaller side is the one opposite the angle, we actually have two possible triangles. One where angle C is obtuse, which is what I've currently drawn, and then one where angle C is going to be acute. And I haven't drawn that triangle yet. That triangle is tougher for me to draw. Okay? But the idea here is that you see this current triangle, right? I don't know if I can do it justice or not. I can try. But the idea here is that if you take this triangle right here, okay, so you still have basically side CA the same. I don't know if I can draw this or not. I'll show you a picture in the book. But the idea that this side CB, because it's shorter, it can slide down under here to be that little triangle like that. Okay? And if you don't like my drawing because, you know, it's not the best, there is a picture in the book it's figure 519. But there's the idea. The top one being my triangle in red, and then the bottom one, ignore the dotted lines for right now, but this little sliver of a triangle being, okay, this CB right here, folded in under that. So we have double the work to do on this problem. There are two triangles to figure out. And I'm going to, for the record, it's figure 519 on page, I think I wrote down 436, if you are wanting a better picture than what I can provide. Okay? Now, for the moment, I'm going to say ignore the blue triangle. We're going to start with the red triangle. Okay, you have to start with this triangle first. We have to start with the one with C is obtuse. So, with that in mind, okay, no different than what we just did on the previous example. I know my A's. I know side B. What do I have to find first? We have to find angle B. Yes? So go ahead and set that up. I'm going to set up so that I have sine A over A equals sine B over B. Me doing the teaching, yes, I write that piece out right there. I'm not saying you have to write it with the A's and B's in it. That's just me trying to make sure you can see later what we did. So sine of 30 degrees over 6 equals sine of B, which I don't know yet, over 7. Same old math, cross products. So 6 times sine of B is equal to 7 times sine of 30. In order to solve for sine of B, I divide by 6, right? So sine of B is going to be 7 sine of 30 divided by 6. How do I actually find B? Sine inverse, good. So I'm going to do, whoops, not that. B is the sine inverse of 7 sine 30 degrees over 6. You know how to plug that into your calculator this time? Okay. Make sure you know what you're doing there. Tell me what you get for angle B. Yep. Okay. So there's 35.7 degrees. That is my angle B. Okay. I was given my A's. I know both my B's. What do I find next? This goes faster if you guys tell me, because you gotta know. You gotta find your C's. Which C do I find first? Angle C. And in order to find angle C, we know that angle A plus angle B plus angle C equals 180 degrees, right? So, what? 30 degrees plus 35.7 degrees plus some angle C equals 180. And angle C becomes 114.3 degrees. And if you haven't already, the last piece you need to find is side C. Are we okay with what we're doing here? We got the basics. Okay. So in order to find side C, I'm going to go back to, I like to use the A's. So I'm going to go with sine A over A and sine C over C. So sine of 30 degrees over 6 is equal to sine of 114.3 over C. Again, we are doing our cross products. Can I go ahead and jump? Can I do the cross products and the divide all in one step? Are we good with that? I feel like cross products is C times sine of 30 equals 6 times sine of 114.3. Then you divide by sine of 30. So C is going to be 6 times sine of 114.3 degrees divided by sine of 30 degrees. Put it in the calculator and we get some magical answer, right? Magical answer of? Have we done it or not? What'd you get?
10.9.
Okay. Good news, bad news. That was just like what we did on the previous example, right? It's using our basic law of sines. Nothing too crazy there. So right here, we had angle B, side C, and angle C all go with that triangle right there. Notice this is where angle C ends up being obtuse, right? It's that big angle C at top. Now, we need a whole nother second set of answers here. Okay. And so the idea, and I don't know how I do this, is that right here, okay, that's the original triangle from above. Again, I struggle with drawing this, I still got the picture up on the Elmo, right? That's the idea that you can use. Originally, so A is still 30 degrees, right? That hasn't changed. Side A is still 6, but side A is now folded underneath. And so side A is right there and is at 6. And actually, I'm going to put equals A there. Side B is still over here and is 7. Agreeable? Now, a big connection you have to make for this to work. You see my side A that folded underneath that is 6? It originally was over here and was 6 over here, yes? So what you're looking at there, and my picture does not do it justice, of course. If you look at this dotted triangle, okay, that's in red with the blue side, what if I say it's an isosceles triangle? This side was originally 6. This side folded under, it's 6 over here, yes? If you have two sides the same, what do you know about the angles opposite those sides? You see where I'm going with this? They're congruent, yes. So the idea, over here in the original picture, this was B, yes? And what did we find B to be? We found that angle to be 35.7 according to our first set of figures. Now, okay, if we're talking a congruent triangle here, follow me. If this is 35.7, then over here is 35.7, which it doesn't give me anything inside my blue triangle, but it gives me the starting step. Do we see it? Because what we know here, because we're trying to work at this new angle B, we don't know what the new angle B is yet, but we know outside of angle B is 35.7.
There's two angles that add up to 90. There's two angles that add up to 80. So can we do that?
Mm-hmm.
And then C also half or 140.
Hold on to C for a moment. Okay, don't talk C for a moment. If we just talk B, the idea is 35.7 and this angle that I don't know yet lay along a straight line. Two angles that lay along a straight line. The vocabulary word he's looking for is supplementary. add up to be 180, right? So two angles that lay along a straight line add up to be 180. So when we go to find our new angle B, and this is where I'm going to try and, I'm using a different color, but so we're going to take this new angle B here, and I'm going to go up here to do my work. Angle B is going to be 180, because they lay along a straight line, minus my previous angle B. And my previous angle B was 35.7. So 180 minus 35.7 is 144.3 degrees. Okay, there's one of my new angles. So you don't have law of sines to find that new B. You have to use your previous information. Now, how do I find angle C? My new angle C, that is. Because basically it's switched. B is the obtuse angle now. C is an acute angle. And go back to the idea of all three angles add up to be 180. So angle B plus, or angle A plus B plus C equals 180. The difference is we're using a different angle B. Still the same angle A. That didn't change. So 30 degrees plus 144.3 degrees plus some angle C is 180 degrees. And my new angle C is very tiny, I guess. 5.7. Okay, I got angle B, I got angle C. Now I need side C. What am I doing to find side C? We're going back to using whole plan of today, law of sines. Okay. Like every other part of this problem, I would go back to using our A's because that was given. The difference is we have a different C to go with, angle C to go with it. So I am going to say sine of A over A equals sine of C over C. So sine of, what was it? 30 degrees over 6 is going to be sine of 5.7 degrees over C. Cross products and divide, right? So C is going to be equal to whatever, 6 times sine of 5.7 degrees divided by sine of 30 degrees. C is very tiny again, right? What is it? 1.2.
So how would you name these triangles? So like the red triangle would be like when B is acute, and this one you would like say when B is obtuse.
Actually, you'd, well, yeah. Yeah, because B was the other side we were given. And so it's, you know, the first, or I don't know, because you could talk about it in terms of B or C. I guess I think of it more in terms, I thought of it more in terms of C, but it's all, you know, basically they flip-flop, right? There's one where C is obtuse, B is acute, and then there's one where it's just the opposite. Okay. Example C. We got that's the hard one. Okay, that is the difficult part of this lesson. You got the basics of everything else. This is going to be the challenge problem. This is where you have to really work hard to figure out all the connections. So, example C. Solve triangle ABC, given that A is 8, B is 15, and angle A is 100. Yes? Okay. Well, angle A is 100, so that's an obtuse angle. So I'm going to draw my triangle a little bit differently here. A is 100 degrees. Side A is a length of 8. Side B is a length of 15. So I'll make that angle B, that angle C, and that side C. Something you have to watch for here that needs to become fairly obvious to you. And drawing the triangle should make it somewhat obvious. Did you guys go back and find it?
That A smaller than B,
Mm-hmm.
so it can't be a triangle.
Yeah. This triangle can't exist. Angle A, the given angle, is obtuse. Okay, if you think about the math, there can only be one obtuse angle in a triangle, right? And there's one, so there's an obtuse angle. The obtuse angle has to be the largest angle in that triangle. So what has to be opposite the largest angle in the triangle? Has to be the longest side. So over here needs to be the longest side. Is 8 the longest side in the triangle? No. And it doesn't matter how I draw it. It's a matter of what other number was given. And 15 was given there. Okay. So officially my answer is no triangle possible. That is my official answer on this problem. It can't be done. And so you want to watch for the fact that they give you an obtuse angle that has to have the bigger side across from it, because there can only be one obtuse angle. And I'm going to write that note here that obtuse angle must have, or must be opposite the longest side. So obtuse angle must be opposite the longest side. Okay? Okay. My hope is we get through example 3. We don't get through example 4, that's fine. There is a problem like example 4 in homework, but I can help talk you through it tomorrow. Okay? You guys good to go on this one? Okay, word problems. Forest Ranger Chris Johnson at Ranger Station A sights a fire in the direction 32 degrees east of north. We have to talk about what that means. Ranger Rick Thorpe at Ranger Station B, 10 miles due east of A, sights the same fire on a line 48 degrees west of north. Hope you guys got your compass in your mind. Find the distance from each ranger station to the fire. Okay. You guys got your compass going in your heads? Do we know our compass? Can I squeeze it in right here? Mine has never eat shredded wheats. You guys never eat soggy waffles? So, I'm an older generation than you guys, that's the difference. So, however you remember it, I don't care. But know your compass, right? Soggy waffles are the best waffles. Well, not according to the compass saying, so. Okay, so we got a forest ranger at station A. Okay? Fancy, I know. Now, he sights a fire in the direction 32 degrees east of north. So where is north? North is straight up, yes? So where is 32 degrees east of north? Well, 32 degrees east of north means over here, because east of north is to the right. So 32 degrees east of north is that angle right there. It's kind of an awkward angle, but it is the angle between due north and the line of sight to the fire. That's 32 degrees east of north. And I'm going to call this point C, but this is the fire. Okay? Then, Ranger Thorpe is at Station B, and it's 10 miles due east of A. So 10 miles due east of A means it's going to be over here. The distance between them is 10 miles, yes? And then he sights the same fire on a line 48 degrees west of north. So where is north? North is straight up, yes? So where's west of north? That's to the left, which makes sense because that puts the fire in between them, right? And then that tells me that this angle right here, in between due north and west of north, is 48 degrees. We got all the information? Find the distance from each ranger station to the fire. So what is it we need to find? We need to find this distance and this distance. That's my goal. Okay. If you want, I've already got my ABCs, so basically we need to find side A and side B, right? Side C is given as 10. Well, thoughts on all these angles here? Yep. So north and east, north and west are going to make right angles, yes? So if we know that 32 and 48, those are outside the triangle, so they only help me find the inside. 90 minus 32 is going to be 58. 90 minus 48 is going to be 42. Does that make sense? And then once you know A and B, can we find C? That's the thing, guys. C, you have to know C, because we need that information. C is going to be what? 80 degrees, right? Because 58 plus 42 plus whatever C is has to equal 180. Sorry, I'm not writing out all that information. Okay, guys. I need to find basically sides A and sides B. Can you do that? Law of sines at this point, right? We've got a triangle. We know our C information. So I can always set up sine of C over C. And then in one case, I'm going to have to do sine of B over B. And then I'm also going to have to do sine of C over C. And set it up as sine of A over A. Right? Those are the two informations you have to find. So, in both cases, we're going to have sine of 80 over 10. To do B, I'm going to have sine of 42 degrees over side B. So in order to find side B, cross product says 10 times sine of 42 degrees is B times sine of 80. So then I'm going to divide by sine of 80. B is approximately 6.8 miles, and that is the distance from Station A to the fire. Same type thing over here, right? Sine of 80 over 10 again. This time it's going to be sine of A. So sine of 58 degrees over A. A is going to be 10 times sine of 58 degrees divided by sine of 80 degrees. .6 miles on this one. And that is the distance from station B to the fire. Okay? The key on this one is getting your picture set up, isn't it? Once you get the picture set up, this is a piece of cake. It's getting the picture set up. Okay? Example 4, there is one like it in the book. Okay, the same example's in the book, so you can look in the book for an example and use that to try and help guide you on the homework problem. Okay? We can talk questions tomorrow. So yes, do the homework for tomorrow. If you haven't already written it down, make sure you write it down. Try writing it down. Gosh. Page 439. 2 through 12 evens. And 20, 22, 38, and 39. Needless to say, I should see some work on these pages, shouldn't I? Yeah, no, I think there needs to be some work written down. So please show me some work tomorrow.